What the
What the
heck
heck is
What the heck is
happening?
What the heck is happening?
Hello, and welcome to another episode of our Trending Topics podcast. Smart glasses are already a thing of the present, but what about smart contact lenses? Not many companies are exploring this futuristic technology, but one of them is Xpanceo, a firm seated in Dubai. Today I'm speaking to Valentyn Volkov, the co founder of Xpanceo. Hello, Valentyn. Welcome to our podcast.
Thank you very much. Hello, everyone.
Okay, so I'm really happy to have you here. I first learned about you at the AWE a couple of weeks ago here in Vienna, the extended reality conference. And I was really fascinated by just your idea of smart contact lenses. Could you just go into this a little bit more? Could you tell our audience what is Expansio and what exactly do you do?
As you said, we are placed geographically in Dubai. Xpanceo, it's a startup, basically. We are trying to deliver, as we say, a next computing category in a form factor of contact lens. So it's a smart device which looks like a usual, let's say, hydrogel contact lens, but this lens is consist of many parts like sensors, holographic screen, some electronics like antenna and so on, batteries, and altogether makes our product, which we call a perfect smart contact lens.
Okay, that's really interesting. But before we get into the contact lenses, a little bit about Expansio. Why did you move to Dubai to found your company? Because you're not originally from there, right?
Yeah, we are not from Dubai originally. Let's say biologically, I'm Ukrainian, and my partner, he is Israeli, but with roots from Russia. We met each other in Russia a few years ago, actually. And then my partner, Roman Axelrod, he actually came to my office a few years ago. In that moment, actually, I was director for the Center for Photonics and 2D Materials placed at Moscow Institute of Physics and Technology. My main specialization, I'm a physicist. I'm doing material science, nanophotonics, optoelectronics. I had a pretty much usual career, like going all the way from PhD student to professor within, I don't know, 20 years or something like that.
Okay, and now you're a founder. Yeah, no, made a startup.
Yes, and Roman knocked in my door. He came with this idea of smart contact lens, and I said, "Okay, let's think, let's talk." So then we start to discuss how this project actually could be shaped. A few years we were kind of playing with that one way or another, and then we got some interest from investor side. So, but one of the conditions was actually that the company should be actually moved out of Russian Federation. So, and which actually happened just before all this geopolitical situation started. So we choose Dubai because it's a very convenient location, I think, for moving business, international business. Our team actually consists of Russian and Ukrainian engineers. So from this point of view, Dubai looked like a perfect neutral territory, which easy to access for everyone. And it's also tax free, which is also
An advantage, definitely.
yeah. So then we moved the company, start to build office lab. So basically now everything is ready. We are top 100% functional. So our team moved to Dubai. So it's more than, I would say, all in all, probably we are around 50 people, including our products, R&D, and so on.
Okay, very interesting. Now to the thing that you're actually trying to accomplish here. A smart contact lens. What exactly can it do? Can it do the exact same thing that smart glasses can do today?
Well, yes, and even more. let's say contact lens itself, it's a very, let's say, private thing, something which is placed very close to your flesh, let's say. And of course, our contact lens, it's suitable to deliver you some ER VR experience, but also it consists of several biochemical sensors which can collect some information about intraocular pressure, for example, of your eye temperature. We also try to deliver several sensors which judge on dryness of your eye, for example, or also fighting on cortisol and glucose sensors, which, well, it's still on a relatively earlier stage of the research, but we are also trying to integrate it into our contact lens. Historically, my research group, we have a very good background in biosensing. So our background now, we're actually trying to apply to this new project.
Okay, I see. I think Roman, when he spoke at the AWE, he said something about giving people superpowers such as night vision or the ability to zoom in.
Yes, absolutely, absolutely. So it's I mentioned this biosensors, but another feature which is we assume rather unique to our project is this night vision option. So this is based on the usage of advanced novel smart materials, low dimensional materials, which we actually integrate inside the body, let's say, or inside the material we use to produce this hydrogel lens. So this allows to do up conversion of the radiation and actually opens the possibility to reach this night vision mode.
Okay, that sounds incredibly impressive and very futuristic. So, can I ask how far are you exactly in this research? Just how much of this actually works right now?
Well, if we are talking about night vision project, it's a relatively early stage. We just applied for a patent and now working on. I mean, we already demonstrated it in the first approximation on the optical table. So now we trying to approach it as much as possible to this form factor of the contact lens. So it's in principle works, but still requires some additional amount of research. Other projects, they are also in a different stage of development. We are kind of did a very well progress in terms of developing biosensors because, as I said, we had a very good background in this direction. Then, of course, we are working hardly towards the delivering of this micro projector, which should be integrated inside the lens. Before this other conference, we just participated in GTEx conference, which actually took a place in Dubai. And those who were there, they actually had the chance to experience this holographic projector integrated in our lens because we had some demo during the conference. So there was a chance to came to our, let's say, stage and try in the first approximation. Of course, it's not really, we don't allow people to put contact lens inside the eye, but you can bring it as much as possible to the eye and then actually you can see some nice images.
Okay, and if you theoretically would put it in your eye, how would it feel?
Well, it works. I mean, some of our R&D guys, they already tried to put in. It works, yes. Just because officially it's not yet certified.
Yeah, of course, yeah.
So we are kind of waiting for certification. Yeah.
So is it a soft, bendable lens?
Yeah, we have like two versions, soft one and the rigid one, like, this scleral one. I mean, actually, we use both. Our final product is supposed to be a soft one, but we also used a lot of this hard or rigid lens because it's much easier first to try on a, let's say, rigid surface and then to be sure that idea or prototype works correctly. And then we actually integrate it inside the polymer matrix of this soft lens. Yeah.
Okay, because I'm very familiar with contact lenses. I'm wearing mine right now. I can only wear soft lenses. The hard ones, the rigid ones, they're not good.
Did you try it? Did you try hard one?
I did. Yeah, I did, but it doesn't work with me.
Yeah, okay.
Since we're already at normal contact lenses, could your contact lens technically correct the eyesight of the wearer?
Yeah, it's absolutely the same. All the functions of the usual contact lens with fixing your, I don't know, myopia or other vision problems, they're still there. And actually, in principle, our lens in the end will be also, let's say, equipped with what we call a zoom option. So, in fact, you will be able to align a contact lens to your eye. And if you have some particular issues, I mean, it can be kind of shaped to your eye, especially. But plus to this, those superpowers are coming. I mean, come together with the lens, like night vision and all the VR, ER, and sensor possibility. They are also coming with the lens.
Okay, very impressive. So, how is that even possible? What exactly is the lens made of? I mean, I believe that these projectors, the holographic projectors, are possible because we already have smart glasses. But how does this work with a contact lens?
Well, it's pretty much, I mean, the same approach. I mean, all the things which you need to integrate into your lens should be really, really small. And that's actually where the main challenge actually starts. Because, of course, in principle, usual smart glasses, they are all based on a, let's say, traditional optoelectronic or optical approach. So where it's usually you use some total internal reflection phenomena to, I mean, also some gratings to couple light in and then deliver it out into your eye. So now, of course, everything is much smaller. So you have to use some new approaches. So we use some novel advanced optical materials actually, which allow us to shrink the dimensions of the optical and optoelectronic components down to say sub-millimeter scale. At least actually they are significantly smaller than that. That's actually opens a possibility to integrate it inside contact lens.
Okay, wow, that sounds really difficult and very hard to do. What made you choose specifically smart contact lenses? It sounds like you kind of skipped a step. Why not just go into smart glasses and why go immediately into contact lenses?
Well, we just believe that it's kind of the contact lens would be the next, let's say, step after smart glasses, taking into account the enormous amount of funds and money involved already in the, let's say, those smart helmets, smart lens area. There is no doubt that this would be probably like the next generation of the electronic devices. And I mean, so it's already the competition in this area is very, very high. So we believe that this would be smarter to play on a kind of one more step forward. So that's, and then of course, taking into account the natural stage for the miniaturization of the optoelectronic devices. So it seems like it's very logical to so after glasses, the lens appears. And again, there are several companies who are actually trying to create smart contact lenses. And if you actually dig through the scientific literature, you can see there plenty of papers coming every year. They're specifically directed toward the subject of the smart lenses, and not that many of them actually trying to deliver some visual content through the lenses, but in terms of smart electronics, smart sensorics, it's a very popular topic. So that's actually seemed logical that taking into account our background in optoelectronics and photonics, smart contact lens would be a perfect subject, even though a challenging one, of course, to try deliver in those upcoming years. Yeah.
Well, you have apparently managed to convince quite a few investors of your ideas. I think you've got a pretty sizable funding actually recently. Could you tell us a little bit about that? How high was it and who was involved in that?
Oh, yeah, we closed around. Those money came from Hong Kong. It's a well-established fund.
I think a number like I think like $40 million was thrown around.
40 millions, yeah.
What are you going to use this new capital for?
Basically, those money are going to be spent to deliver basically smart contact lens within the next few years. Actually, according to our roadmap, we promise to deliver a working prototype of a smart contact lens in the end of 2026.
2026. Well, that's pretty close actually. And but with all the excitement, I have to ask, just realistically, how much could this possibly cost? Because smart glasses are already pretty expensive, and I mean, I'm pretty sure contact lenses are at first going to be very expensive.
You mean to cost once it's again? You should keep in mind that here I'm not really talking about mass production of the lens within this short period of the time. So to mass product such a product, I think it will take some additional amount of years, probably I don't know, a few more, maybe 5 more years. But right now, for obviously the prototypes that we produce in our lab, state of the art, of course. I don't know how expensive they are. Well, one can probably calculate this, the price just taking into account the number of hours and salaries which we spend on a project. I mean, in terms of taking people to push the project. Well, it's pretty expensive. I would say one should, again, keep in mind that the project is very ambitious, and that's why the amount of investments which we ask for it's significant. Yeah.
I see. But I definitely see some incredible future potential in this technology. I need to tell you about my vision. I basically, an aunt of mine has lived in Hong Kong for a few years, and she said she couldn't drive her car around because she just couldn't read the street signs. And I thought, with all these advancements in AI and connectivity, I thought maybe smart glasses could in the future be able to visually translate signs like this, writings like this, perhaps even another person's voice and give you subtitles.
Sure,
Do
sure.
you think that
Yeah.
there could be a possibility that could also be implemented in those smart contact lenses?
Yeah, we are considering actually to also to connect a function of, I don't know, maybe translate or GPT chat. I mean, to get, I mean, those possibilities, they're theoretically speaking, they're endless. I mean, we also, develop this concept of neural interfaces. Again, right now it's at relatively early stage within our project, but again, we just applied for a patent.
And a technical question about the lenses: how exactly are they powered? Because they need energy from somewhere, I suppose. And how does that work?
Yeah, that's a good question. So we actually right now we are considering three main power sources. So first of all, there is an antenna integrated in the lens, so it's actually allows you to do, let's say, a wireless connection or and transfer of energy. It works in a first approximation. Then, of course, we also integrate the biocompatible batteries. I mean, we do not develop our own battery right now, so we just use those that are available, the smallest batteries that are available on the market. And as a side project, we also develop our system of compact solar panels, which are integrated into the lens. So just I mean, the contact lens, it's something which is supposed to be nicely illuminated, and under the perfect conditions, the light goes through the lens. So the idea of integration of solar panels inside the lens makes sense. So we are kind of also digging in that direction as well.
But you probably shouldn't stare directly at the sun with those lenses. It's probably not the best idea.
Well, yeah, there are lots of things which still waiting for solution. Let's say, yeah.
I see, yeah. Well, that's really interesting. You can probably tell that I'm very enthusiastic about what it could be. And but with the way tech is going right now, I'm also kind of worried about what it could become in a negative way. For example, I'm kind of worried that maybe you're just going to get bombarded with ads, with visual ads, while you're wearing the contact lenses. Do you think that's a possibility? That's a sort of threat to the technology?
Yeah, well, sure, but that's why you need to have some kind of proper protection. I mean, it's like, I mean, it's pretty much like, like advanced mobile phone or something. I mean, Sure, of course, it should be properly protected also from some viruses and so on. Again, our lens it's not a standing alone device actually. In fact, because one should keep in mind that we are not going to put a huge computing power on the lens. The main, you say, computational powers, it comes together with this what we call the partner device. It's like a small. It could be also your mobile phone as well, but we are developing. It's like a small box with the screen, and actually it's also a box for where you can keep your contacts when you need, for example, recharge them or something like that. So it's wirelessly connected to your lens, and in principle, it's a small computer, of course. And yeah, then of course you need to protect it also in terms of, let's say, viruses and other unpleasant and unwanted actions. Yeah.
I see, yeah. Okay, and now for the last question. How do you see the future of Xpanceo? What exactly do you want to achieve in the coming years? And do you see a mass production, like a mass use of your contact lenses as possible?
Well, again, I'm afraid that for the next few years we'll be thinking not about mass production, but be more occupied with engineering problems related to our roadmap. So that's our main target right now. So we have to deliver now those prototypes of our lens as we promised. So as I said, the mass production is something which we are considering like done, I don't know, maybe 10 years or something, because it's more occupied with problems related directly to our product and to our roadmap.
Okay, well, I very much hope that you succeed. Thank you so much for joining us today. Thank you, Valentyn.
Thank you for your time.
So, this was Valentyn Volkov of Xpanceo. And with that, we have reached the end of this episode. Thank you for listening, and tune in next time when we once again welcome exciting guests into our podcast. Goodbye.